We have today a Docker workshop. We scheduled, as you know, probably you're here because this is the Docker Tel Aviv meetup. We scheduled 2 workshops. Today, we will mostly be focusing on Docker, and the next workshop on the 22nd will be about Kubernetes. These are not workshops for beginners, so if you have no idea what Docker is and you haven't used Docker before, it will probably be quite difficult to kind of follow. Okay, this is on purpose a workshop to expand the knowledge of people who already use Docker, to kind of go into some corners that are not usually discussed in such depth as I will try to discuss today. The workshop is composed of several sections, several relatively short sections, where you will be doing, you will be learning on your own with your computer or with your friend's computer. You don't need to install anything. All you need is the Wi-Fi, which is, the password is up there and here, and the browser, okay? So what we'll talk about today, we'll talk about a couple of ways to extend Docker, to kind of do things beyond what the usual basic usage of Docker is. We'll talk extensively about Docker networking, what that is, what are the possibilities, how it works. We'll touch a little bit about Docker volumes, which is also the possibility to extend Docker to use different kinds of volumes. And hopefully we'll have enough time. I'll teach you how to take an image and make it 1,000 times smaller at the very end. So those of you who haven't yet registered, please visit the website playwithdocker.com and create an account. On that website, you will have an environment when you can create instances that have Docker installed and everything, and those instances are alive for the next 4 hours. Okay? In some cases, you might think, no, I don't need Play with Docker, I'll do it on my computer. But in several of the workshops, of the Learning by Doing workshops, I'll ask you to create multiple computers, multiple instances, like 2 or 3, and you will not be able to do that on your laptop. So you kind of have to use to Play with Docker. Okay, so a couple of words about the popularity of Docker. This meetup has been around Tel Aviv for about 4 years now, and every time it's fully booked, it's packed. The amount of images being pulled from Docker Hub is growing exponentially. This is becoming a technology that is a commodity. Everybody is using Docker, and you probably know this. That's why you're here, right? Now, I'll jump straight into the subjects. So, as you might know, Docker is composed basically of 2 parts. One is the Docker daemon, and the other part is some client that talks with the daemon. Okay? One of the first things that people learn to do when they use Docker is run the docker run hello world command. And that command will usually print this output and explain what it does, what is happening behind the scenes. So if you have Play with Docker running right now, you can create a new instance there and run the command docker run hello world. And let's discuss a little bit what is happening. So the command docker that you actually run is the client, right? It talks with the Docker daemon, which is kind of the server side of Docker, and tells it I want to run an image called hello world. The daemon checks if he has that image locally in his cache, and most probably it doesn't. So it goes to some kind of registry where images are stored. By default, it will be the hub.docker.com. And it will try to search for hello world image. Once it found it, the second step is it will copy it over to its local cache. Okay? Since we asked Docker to run the image, it will create a container. So I will try to be precise in terminology. When I say image, it's a program packaged inside of a Docker image. And when I say container, it is a running process.
Okay.
Maybe you can ask for permission to take chairs out of those rooms or something?
There is no possibility, as we have two events that are
Okay.
in the rest of the room.
Sorry.
Sorry.
So, and then, who is running this container? What is the process that is running this container, right? The process that is running the container is also the Docker daemon. And should that Docker daemon be on some host machine, usually Linux, then that container will be running on that Linux machine as a Docker container, correct? The client, whoever asked from the daemon to run it, doesn't necessarily need to be on the same machine, but it will, in stage 4, as you see here, will receive the output, will receive the standard output of that running process. Okay? Now, can anybody tell me what's so special about Docker? What does it do? Not why it's good, but what does it actually do in practice? Anyone?
It uses namespaces and C groups.
It uses
In the kernel.
namespaces and C groups
Inside the kernel.
of the Linux kernel. Who knows what a namespace in a Linux kernel is? Please raise your hand. Okay. Crickets. So let me explain. In the Linux kernel, we have processes. Usually, when these processes run, they have a table of processes. You can use the command ps in Linux and see the table of processes. There is an ID for each process, like PID1, PID2, and etc., etc., etc. What Docker does is one of the namespaces in the Linux kernel is the process namespace. So when it runs a container, that container will only see the processes running in the same container. It will not see processes running in other containers, and it will not see any processes running on the host. Okay? That's an example of a process namespace. There are multiple other namespaces in the Linux kernel. For example, there's the networking namespace. So when you look in Linux, when you look at your network devices, you will see maybe ETH0 and LO0, right? All of these network devices that have IP addresses. The Linux kernel can create another reality when there are other network devices. So what Docker does, it creates a process, the one that is in the image, and for that process, it creates new namespaces, new networking namespace, new volumes namespace, so it will see different mounts, new process namespace, new user namespace, which is the user IDs in Linux, and etc., etc. Okay? I won't go into C groups, but C groups is a way in the Linux kernel to tell a process how to limit it, how much CPU to give it, how much memory to give it, and then so it kind of thinks that it has less memory than the really physically is on the host. So, any questions about what Docker does? Basically, what Docker does, it takes complex commands to create these namespaces that have been around Linux for a long, long time, and it turns them into a very simple UI. okay, user interface, where you write Docker run, and it does all of these namespacing and everything for you, and you don't even think about it. But as I said, this is an intermediate workshop, so we'll need to kind of understand some of the things that are happening there.
So the Docker daemon is actually doing the C group. The C groups is
Right.
for you. It's not running on a layer of Docker daemon, like virtual machine is running on the layer of some.
So yes, let me expand on that. So when you have two different computers and you tell the second computer to run something and the first computer to run an application, you assume that these two computers, these two applications will not see each other, right? These are two separate operating systems. In Linux, containers allow to take parts of the operating system, like the PID namespace, like the network namespace, and separate them, but they will still use the same kernel. So when the Docker daemon runs an image, it creates a container. That's how a running image is called, a container, right? And that container is isolated in several ways, right? So,
Just a question.
yes.
I understand that there is also an application of Docker for Windows. It's still using Linux.
Okay, so there is an application of Docker for Windows, Docker for Mac. In the case of Docker for Mac, there is a virtual machine that is being created by this application. And on that virtual machine, the Linux is running because Docker can run with the Linux kernel. On Windows, you have two options. The newer versions of Docker allow to use the Windows kernel in a very similar way, but we will not be talking about that. It's a kind of an experimental subject. It might work, might not. Kind of learn it on your own. So, has anybody run this command in his play with Docker? Docker run?
Decide this issue. This is not the natural, it's the framework.
No. No time. Okay, so you saw the output?
Yes.
You read the output? Can you concur that it's kind of similar to this? Maybe I made a mistake and you can correct me? No? Okay. So, when the Docker client talks to a Docker daemon, right? It uses the API, the REST API that the Docker daemon exposes. The Docker client is just a dumb REST API client. It doesn't have any sophisticated functionality inside of it other than recognizing the commands being used and sending those via the REST API to the daemon or to the engine. It's also called an engine sometimes. That engine is running on a Linux host, on a server basically, and there it runs all the containers. Okay? So there's a way to set the endpoint where the client will be sending its commands. Where is the default endpoint other than you? Can anybody say? Localhost, that's incorrect. What's the default endpoint where a Docker client will be sending his commands to the daemon? The Docker socket.
Docker socket.
Yes. The Docker socket is var Docker socket. Okay, it's very small, but what is a Docker socket? In Unix, everything is a file. You heard that one? Which means that when you make a connection via the network in Unix, you're basically creating a file, okay? When you create a connection, network connection in Unix, you can also connect to a file, to an actual file on the file system. That file is usually called a Unix socket, okay? So the Docker, by default, the Docker client, unless you specify otherwise, will look for this file and talk with the daemon using this file. It will send commands to this file, and that's how it will work. Okay? unless you specify an environment variable called Docker host, and then you can set maybe a TCP endpoint, maybe some other server where the daemon is running, and you can send command remotely to other places. Okay, understood? Now, as the question was before, when you're running on a Mac, your client will be a Go application running on the Mac itself. It doesn't need anything special, but it will send its commands to a virtual machine that runs Linux, and that's where the daemon is running. Okay? When you're running on Linux, usually you would not need a virtual machine, but of course you can also use a virtual machine if you like. Now, what are the commands that are being sent? Okay? So if I want to see the list of containers, can you guess the command?
ls.
Yes, but what is the rest? That's correct. That is the command that you will type to the client on the command line, and then the client will send the REST API request. What will be that request? Something like, I'm guessing here, /containers/list. A GET request. Okay? So, this is a trick question in many ways. What is the protocol being used by the client to talk to the daemon? Okay, so these 7 numbers is the OSI model of networking layer. In each layer, there are multiple protocols. And can anybody? HTTP, yes. Do you know how an HTTP request looks like?
Yes.
There's a GET or a POST, right? There's a path. And that would be the application layer. That's one protocol. What's the next protocol? TCP is the transport layer, that's correct. Usually you would use TCP, but sometimes, as we already said, you would use a Unix socket. It's not TCP, as far as I know. Anything about presentation and session? Any ideas?
Sage.
What? Talk louder because I can't hear. So. Okay, so SSL, right, can be one of those layers, which means when you talk to the Docker daemon, you might be talking HTTP plain text, or you might be talking HTTP encrypted. Okay? And then, of course, all of this is basically just physical stuff. Yes, question?
Can you elaborate a little bit about the authentication between the client and the...
Right. So, by default, when the client is talking to the daemon, there is no authentication and there is no encryption. We can set up an authentication and we can set up encryption. We'll not do it today, but I left a link to the documentation where it's shown. I will discuss it a little bit. Okay? So now that we know, like we really, really know how these two talk to each other, let's eavesdrop on them. So you have your servers. Let's install an application called soulcare. Soulcare can create a listening port. In this case, it will listen on the 8080 port, and everything sent there will be sent to the socket. Okay? And that will allow us to run Docker commands by sending it to the TCP port and eavesdropping on the communication between the Docker client and the Docker daemon. Okay? So please do it now. I'll give you like a minute. This at the end here is just I'm killing the background process that is executed on the first one. I will share the presentation on the meetup group after this. So there's also going to be a video. Notice that the first command is you need to install soulcare. It's not available on the Linux in Play with Docker. The second command, notice the ampersand at the end. I'm sending it to the background, so it will still output whatever it's doing. We are stopping it at the last point, but here, notice the ampersand. This is the backgrounding thing. And then also notice that when we run a command like docker version, we can prepend the environment variable that will affect only that command, and that's what is done here on the third line. We only change the environment variable for the docker version command. That's the only command that's going to be using the different Docker host.
On Windows, if I see that
As I said, please use Play with Docker. Don't install Docker on Windows or on Linux and then ask us to support, because so many people, it will take a lot of time. We'll not be able to do all the things. Okay? I'm sorry.
I have it. I already have it. No,
Yes.
My question is if I have to do it in the...
Again, please use Play with Docker. If you're not using Play with Docker, it's a bit of waste of time. There's a lot of people here.
No, it's okay. I played a little bit.
Okay.
I played it a little bit.
No, open in the browser. Let me go there again. Sorry.
Okay.
Go here. Okay. If you're not using this, please.
Okay.
Doesn't work already.
Okay.
Sorry.
Too many people.
They need to do service local style. Not right there.
Once you create. Sorry. Let me try and do it with you. So those of you who didn't have a chance to have it working, let's see that it works. Okay. So here you can see that I'm on Play with Docker website, and I need to create a new instance, and hopefully it will work. Here you go. I have a new instance. Okay. This instance already has Docker installed. Let's install soulcare. Okay, soulcare is installed. Let's do the eavesdropping thing. Okay, so soulcare is running in the background. All right. Next. Oops. Try again. Okay, so now what happens is I am running the Docker version command. It is being sent to this TCP socket, okay? And then you can see the actual REST API requests that are being sent. So you can see that the client sent a ping request and then received an OK, and after that it sent a version request using the HTTP protocol, and it received all the headers of the HTTP response and a JSON string that shows the version. All right? How many of you got it working? Most of you. Great. And at the end, I'll try. I'll kill this job using kill one. Come on. Okay, so kind of cleaning up after myself. So, what have we learned here? we learn how to do a man-in-the-middle attack on a Docker daemon, basically. Okay. You also saw that it's not encrypted. The communication is HTTP. So basically, what this means is it means a lot of things. For example, if you want to use an HTTP load balancer, you can put it in the middle between your Docker daemon and you, right? You can do lots and lots of stuff. Now, to the question of encrypting and securing, I will not kind of go into this because it's a bit hard to set up using Play with Docker, but I will explain how this works in general. There is an option to run the daemon with OpenSSL keys. So you need to provide it a couple of options, like TLS verify, and what's the key to use, and what's the certificate to use, and which port to listen to, etc. Okay? Then, when you run the Docker client, you need to use the same credentials. And what will happen is the Docker client will only talk to this Docker daemon because it has the same credentials. If you try to use this Docker client with some man in the middle, someone who doesn't have the same encryption keys, it will refuse to work. And the same is vice versa. So when the daemon is receiving commands from clients that are not using the correct keys, it will fail. All right? Of course, every time you type the Docker command, you don't really want to add all of these options. So what you can do is you can put these files in .docker and just export a variable that says TLS verified, and it will make sure that all the communication is encrypted. Okay? So this would be just too hard to set up using Play with Docker and take too much time, but this is the basic principle of how you can secure the communication if security is a major concern for you. Any questions about this? Yes. Okay, so the question is, if you're just using Docker on your own server, the client and the daemon is on the same server, why do you need the security? And of course, the answer is you probably don't. But if you have some other use cases, I don't know which, time will tell, then maybe you will be reminded of this workshop and kind of say, I can encrypt the traffic. It doesn't have to be plain text.
Sometimes it can be another one. I don't know.
Okay, so the question is, can it sometimes be on another host? When you run the Docker client, as I said before, you set the environment variable Docker host using basically a TCP IP address and a port number. And that host, in many cases, is a VM running on your Windows or your Mac. In other cases, it can be a Docker running in some cloud or in some data center. It doesn't have to be on your laptop, okay? And that communication can be encrypted optionally. By default, it's not. Okay, so let's kind of think and imagine what we can do with this. As I said before, we can do a load balancer for Docker daemons, right? We can record all of the requests. We can create an access log, which will log all the requests done to the Docker daemon. We can do so much just by knowing that it's an HTTP protocol over a TCP port, okay? And we can eavesdrop. Now, let's talk about another way to kind of use Docker for our advantage. Docker events. Anybody knows about Docker events? Heard about it? No. One of the REST APIs of the Docker daemon is called events, and that is a blocking API, which means when you call it, the call doesn't return, it will keep sending you data all the time, okay? What Docker events does is shows you an audit trail of every event done in a Docker daemon. So when you start a new container, it will show that a new container has been requested to be started. If it needs to pull an image, it will show you that an image has been pulled, etc., etc. So very similar to what we did previously, I want you to type in these commands. on the first command, we will run the Docker events blocking command in the background using the ampersand. Then we will run a simple container, just executes the true application. It doesn't do anything, it exits immediately. And once you type in the second line, you should be able to see all the events being spit by the Docker events CLI command.
It's acting like a log, actually.
It's acting like an audit trail of all the commands being executed, yes. If you like to redirect it into a file and then treat that file as a log file, you can of course do that. There are many things that can be done with this. We'll discuss a couple of possibilities. Is the presentation available? I will send the presentation after via Meetup. The longer learning by doing workshops will have a document that you open in your browser and follow. This is just the short things that you kind of need to copy and understand what you're doing. So, has anyone got some output from running a beam true command?
Does not mean the same line?
You don't have to do the last three commands. We can let's first get the first three commands working and see that it works, and then I will explain how we can prettify it a little bit. How we can make it prettier.
Oh,
So it's
prettier.
Sorry?
So do we need to explain what's the
Yes.
So we see in JSON. It's really
Let me-
simple format.
I will explain what we are seeing in a moment. I want to give people an option to experience it on their own. This is a workshop after all. Okay, so has anybody seen any events? Yes? Yes, great. So let me also do this and show you what events I'm going to see, hopefully the same ones as you. So first I run the events command in the background. It doesn't do anything, but it is running. Okay, so the --rem argument will say that when this container is done, basically when the command is finished, it will remove the container, okay? Because containers can remain in a stop state after we run them. So I run this, and you can see that it didn't find an image locally, and it started pulling it, and then said pull complete. And then the digest of the image. All of these lines are part of the, These lines are part of the docker run command, okay? This is the output of docker run. I asked you to redirect it to dev null so it wouldn't interfere. But all the other lines, you can see there are timestamps, and then the events endpoint tells you what is happening. An image has been pulled. A container has been created. A container has been attached. A network has been connected. A container was started. A container died. Network disconnected, and container was removed.
So this is actually how it outputs to Prometheus.
Most monitoring systems, like the question is this the output that Prometheus takes? Most monitoring systems hook up on this events endpoint and basically just read from it all the time.
Docker doesn't have something differently that saves your commands or containers.
Is there anything else in Docker that saves your
Yeah,
command?
like logs, everything. You don't have a command for history or something else like that you
Oh.
can see this.
That's a good question. Is there a command to see history, right? Is this thing logged anywhere? In fact, it is. If you look at the help of the Docker events, which I'll show you in a second, you'll see that you can see previous events as well. Let me show you. Okay. Come on. God damn it. Okay, so of course every command with the Docker client has the option to see some help, and it usually is very useful to see the various things you can do with it. For example, you can provide a since timestamp, and it might work. And of course, you need to kind of guess what the format is. It's probably ISO 836, whatever. But it is possible. Now let's look at the second portion here. It's the same thing, but with the small exception of having this format option. Most commands in the Docker CLI have an option to format their output. I will be using this quite a lot during this presentation and workshop. So you can format the output using JSON. As you saw previously, the Docker events command, the first one, just display timestamps and text. This will show the same thing, but it will encapsulate it in JSON. So the timestamp will be a timestamp field. Text will be kind of the command field, etc. Okay? JQ that is being used here over the pipe is a very useful querier and prettifier of JSON. So once you use JQ-C, which is compact mode, and a dot, it will prettify the JSON and make it all colorful and human readable, more or less. And then basically we are doing the same thing. Okay, so let me demonstrate it, and of course you are welcome to try it on your own as well.
How did you make it full screen for the command line?
Alt Enter, I think.
Oh, thank you.
Okay. Come up. Okay, so it's exactly the same thing, but it shows the output in pretty JSON, and if we really like to, we can send it to our log aggregation service or whatever it is, and useful. Now, since the Go client and daemon and all the other stuff in the Go ecosystem are written, I said Go, I meant Docker. The Docker client and Docker daemon and all the other stuff in the Docker ecosystem are written in Go. The syntax here that you see, the JSON dot and the curly braces, is the Go template syntax. So the documentation for this is in the Go language website for the text template something. It's a bit hard to find, but it's very useful that you can do it this way. Okay, so anybody got some pretty JSON out? Great, let's go on. One of the first and more common and more popular tools that were created that eavesdropped on this events endpoint was interlock. I will not go into high detail about it, but what it does is discovers which containers have been executed, started, etc. And based on that, it will create a configuration file for nginx or HA proxy, which are popular applications for load balancing, and refresh their configuration. So if you want to have kind of a very uncomplex, stupid load balancer, you can use interlock. It's of course running in a Docker container, listens on the events endpoint, and generates configuration for nginx to know which ports and containers it needs to send requests to by being a load balancer. Is that
built-in in Docker Swarm.
too much?
No.
Okay,
Good, yeah.
great. So
You're
some
built-in
of
in
you
Docker Swarm.
will get in there. Okay, so next subject. The first subject was kind of extending and seeing what we can do with Docker that we don't normally do with Docker. The next subject is the subject of Docker networking. It's a big and complex subject. I'll try and explain it as simply as I can, but do ask me questions. So, at the beginning, yes?
Is it possible to see in events also information requests?
Like version?
For Docker.
Is it possible to see in Docker events requests for information like API calls, like version or something? I think it's not visible there, but I don't think so. But you can listen on the API, so we already showed that. Okay, so Docker has been moving towards allowing pluginability or extendability in its various subsystems, and networking is one of these systems. Starting from Docker 1.7, they have released something called libnetwork, which creates an interface for the Docker daemon to create more device network drivers, okay? So, of course, again, this is an intermediate workshop, so most of you already are familiar with the bridge network device. I will discuss it a little bit. The bridge device is the default device that you get when you run a container, but there are other types. There is the host network, there's the null network, okay? Then in version 1.8, there was a sort of a service discovery thing where you could ping other containers by their name and it would work somehow. They later changed it. Then they added a network that will span multiple hosts, the ability to add external plugins, the ability to manage IP addresses and all of that, IPAM. And they have been adding more and more features to the networking stack of Docker since then. So let's explain the basics. What is Docker bridge networking? Okay, as I said, that's the default network you get when you run a container. It basically means that all the containers are connected to the same network. Like the router you have at home, all the computers that are connected can see each other, right? The same with containers over a bridge network. What? Container. Yes.
Just a question. You said router, but it is like a bridge.
No, it's a bridge. It's not a router. Sorry. No confusion here. It's a bridge. So for those of you who know networking much better than myself, it's a bridge device. A bridge device takes multiple network interfaces and allows them to see each other and send requests to each other. Okay? Now, as we said at the beginning, there is namespaces involved. Okay? So Linux has the host, the server. And on that server, we need to create an entity that is called a network interface. That network interface in Linux is called Virtual Ethernet, VETH. And when we create the namespace for the container, we turn that virtual Ethernet into kind of a real Ethernet device for the container to use. Okay? That's why the host has an ETH0, which is usually a physical card. And every container also has an ETH0, which is a copy of the, or it's the same one as the VETH on Linux. Okay, understood? Networking is a bit complex, so the bridge device in Docker is usually called Docker 0, and it connects all of these VETHs to itself. And then containers that are connected via the same bridge device can see each other.
Each new network actually creates a new Docker 0 interface? I mean, if you start multiple networks.
So if you start multiple networks, does it create new Docker X devices? I don't really know what it means, multiple networks, but you can create with Docker multiple bridges. We'll discuss it in a second. So if you have two different servers, each of them running Docker, each of them has a bridge device, right? There are containers. Of course, these containers can have the same IP addresses, right? This is 1802, that is 1802. Because these are different bridge devices, there's no problem. There's no collision of IP addresses, okay? And then you have your external network, like the internet or something. Now what happens when this container tries to ping basically something that it thinks it wants to ping this container? Can it do it?
No, you have to expose the port.
Sorry, louder, sorry.
Looks like the bridge device is also
It's a router.
No, it doesn't look like anything because these bridge devices are bridge devices. It doesn't look like a router. It's a bridge device.
No, you have the router there.
This is the internet router. This means that this server can see this server.
Yeah.
But it doesn't mean, right, that devices connected on this bridge device can see devices connected on that bridge device.
Right.
Right? Sorry? Yes, the host itself also has the IP address of the bridge device, which is usually .1 at the end, and it can talk to the containers, and the containers can talk to it via that IP address. But the problem with the bridge driver is that when you have multiple hosts, the containers of these hosts cannot talk to each other. Okay, it's not possible. It doesn't work like that. And as I said before, you can create multiple bridge networks on the same host. Again, this container and this container will not be able to talk to each other. They're on different bridge devices. Okay, so as you, again, probably know, you can map a port, right? So what happens when you map a port? You say, my container has some service listening on the port, on port 80, and I want that to be available on the host IP address on some other port or the same port. Okay? The command is docker run, and then you specify the host port and the container port. But what is happening actually behind the scenes, right, is there's not a network address translation happening. Because
It's kind of a path. It's like a port address. Okay.
some people know networking much better than me. They can be more exact in the terms. I might not be saying the terms entirely correctly, but excuse me. So when you have the external network of the host, that's the network cloud over there, and then you have a request coming in, right? Something on the host needs to answer that request. The container cannot answer the request because it doesn't have a network interface on the host, correct?
Yes.
So there is a process that Docker is executing called Docker proxy, and that will be listening on the port. And then over the host bridge device, it will be able to send it to the container. But then when the container wants to reply, it needs to reply to the same address that it gets complex here, and we don't actually need to understand it because Docker does it for us. That's the nice thing about Docker. Instead of all this complexity, it just works. Okay? Just only one thing to note is that network address translation in Linux is happening using IP tables, which is the firewall application, and we'll meet that in the workshop material. Now I'm kind of jumping ahead a little bit to talk about service discovery. For those of you who don't know, service discovery is having multiple services, applications, running maybe in containers, maybe not in containers, listening to various ports at various places, maybe not on the same instance, maybe on different hosts. But what is common to all of them is that all of them register themselves, their address, the way to connect to them, in some central database. Okay? And that is service discovery. Okay? No, there's the other part. Somebody, some other application who wants to connect to these places needs to first ask the database where the service is. Okay? And only then it can know the address and send the request. Why is this useful? So basically, what's written there is that every service register, and in some services, you have multiple containers on different hosts, and they're all the same service. Okay, they're all the same backend. They're all the same backend. I don't know. Okay, so all of these also register, so the load balancer will be able to know where everything is, and then we maybe have some smart DNS that can provide the data of this database via the DNS protocol, which is very useful. And this is usually what we get when we talk about service discovery. Yes?
This architecture you're describing right now, is this something? How do I see it in Docker? That is the question.
Okay, so this architecture called service discovery that I was describing just now, how would you see it in Docker? So before Docker had more elaborate ways to network, as we said before, you had multiple hosts, you had to map all the ports, you didn't have much choice, it was mandatory to write all this data somewhere in order to use it. So that's why service discovery is a big kind of mandatory thing that you have to do when you have multiple services. These days we have better ways to do it, and that's why I'll explain why while service discovery is still very useful, because for different reasons, not for networking reasons, when some service wants to access some other service and it only knows its name, it doesn't know the address, it's not hard-coded, it needs to ask someone. That's where service discovery is useful. But for networking, there are better ways to do it. One of the ways is the overlay network of Docker. Okay? What is an overlay network? So Docker said, well, all of that, connecting all of those bridges and everything is very complex. Let's make it easier for the user. So basically, when containers are executed on these hosts, and the user is saying, I want these containers to connect to the overlay network, they will all see each other, even though they're on different hosts. Okay? how it works, magic. Okay? Cool. So, if before, as I said, if before we had to write all the different ports of all the bridges to some service discovery, now we don't need to do that anymore. We can just create an overlay network. Everybody sees everybody, and that's it, more or less. So. Right. So let's explain the difference between service discovery and what a service is. Okay. I don't understand the question, but let me explain the answer. So with Docker, we have something called services. It's a feature of Docker Swarm, an orchestrator, etc., etc. When you create a service, you give it a name. The name in this case is web. You also give it how many of these you want to run, and how many of these is how many tasks. Okay, the terminology is task. So you have a service, it has a name called web, and you have a task called web 1, web 2, and etc. Service discovery will allow you to ping web, and it will also allow you to ping web 1 and ping web 2, because you can either ping the service or ping the tasks. Okay? So in this example, we created a overlay network using Docker with Swarm over two completely different hosts. Maybe they're in completely different parts of the world. But when we created the service, these two containers know about the IP address. They don't have collisions between them. They can talk to each other, etc., etc. Yes. I'm not sure that there is a DHCP. There is something called IPAM, which is basically which IP should I give this container when I run it. So Docker, when it runs the container, it uses the overlay network to know which IP it should assign. Okay, there is no kind of DHCP server running, sending broadcasts on the network and asking, what is my IP address? When you run a container, the IP address is set for that container. At the moment, it's executed.
I think you can tell him what the range of the addresses is that you can give to the containers. I think I saw something like this.
I don't know this claim, so maybe it's true, maybe it's not. So that's why I won't repeat it. Anyway.
Docker Compose is simple, more simpler. It also uses service detection.
Okay, there's something called Docker Compose. Again, it's
simpler.
out of scope of what I'm talking about now. Docker Compose, again, let me go back a bit. Docker services and overlay networks only work with Docker Swarm, which is an orchestrator. Docker Swarm makes these two hosts and the two daemons be aware of each other. Okay? Without Docker Swarm, you cannot have overlay networks, you cannot have services. Now, as the gentleman here said, there's something called Docker Compose, which is a way to define the services in a YAML file and run it. So instead of writing Docker service create, you would create a YAML file where there would be service and...
on a single host, it's not a multiple.
No, it works with Swarm as well.
Ah,
yes,
okay, three.
So that's why I don't want to talk about Compose. It's not part of our material today. Maybe next time.
How do they know the names of all available services?
Right. How can you know the name of all available services?
Maybe because maybe it grows up and there is a left 1 and 2 and 3 and maybe 4. How do they know it?
Right. So how will you know the names of all the available services? And let me be exact here. A service A and service B are unique. You cannot create two of service A. But with a service A, you can tell the amount of replicas it will have. That's tasks. You will have in service A task 1, 2, 3, 4, and etc. And we'll learn, and you will do it on your own. You can actually inspect the service and see all the tasks that are running, where they're running, and etc. And all of that. Okay. Another thing we can do with the service, we can publish the port of that service. Okay. And if we have two containers, because we have replicas too, and we publish the port will be published on each of the hosts. Okay. Now, let's see one caveat of that. If we have 3 hosts and we publish a port, for example, 8080, right? There will be a process running on each of the hosts, listening to port 8080, even if there are no containers, no tasks of that particular service running on the host, on that host. Anybody can guess why it's useful? Sorry?
Maybe elasticity.
Elasticity. It's very useful because when you have some amount of servers, you don't know how many, and you have a service that is running somewhere in there, and you just know the port number, you can put a load balancer on all of the servers. So if a load balancer is outside of this, you can just point the load balancer to all the servers. You don't need to kind of cherry pick and know where the service is running its tasks at this moment. Okay? Cool. For example, I have a load balancer, HE proxy. It sends requests everywhere, and Docker is doing the hard work of finding out where these requests actually need to go. Okay? So, any questions about networking, bridge networking, overlay networking?
Does it work only with Swarm?
Yes, overlay networking will work only with Swarm. Yes. Any more questions? All right. So this is time for you to shine. This is the short URL where you will find all the knowledge you have ever wanted to know about Docker networking, more or less. Please let me know if it works. It should work. On that URL, which I'll open in a minute, there are very simple instructions that you can type into your Play with Docker website that you started, and kind of feel it on your own, how it looks like, how it works. Bridge networking, overlay, Swarm, etc.
Okay, we open the document, so we can try these comments on the yes.
I see you're sending me suggestions. That's great. That's really, really good. I don't think I'll have time to address them right now, so ask me a question as well as a suggestion. But everybody can comment on that document and if it works.
And the comment on the labs or the comment it's for the labs?
What do you mean for the labs? I will see the comments afterward.
I should insert the comments in the terminal or in the lab?
Okay. Let me see. So whatever is written here in the square, let me enlarge it a little bit here. So whatever is written in the square things are commands that you can copy paste into the Play with Docker, and copy paste them one by one. Don't copy paste the whole block of their kind of multiple commands, and try to see what the output of each one and understand what it means.
So okay.
That's it. Now it's not bothering anyone.
This is the longest document that there is. There are a couple more, much shorter, that we'll do after. So when you finish this one, let me know by raising a hand or kind of catching my eye or something.
Okay.
So let's try and cover a couple more subjects. If you like to stick with this, I'm fine with it. But so have you learned new stuff? Yes, excellent. That's what you're here for. I am. A couple more. Some history about networking, about Docker networking. Okay, so what we have been using right now, the overlay network, is a lib network, sponsored by Docker, created 2015. Just so you know, most of the orchestrators, Kubernetes, ECS, etc., Mesos, all of them, other than Docker, they all use a different plugin model for network drivers. It's called the CNI. Okay, so there's a bit of history here. CNI was created about the same time as Docker Lib Network in I think 2015, and Docker wanted to support it, but then they decided not to. There was a lot of politicking and etc. Anyway, some projects like Kubernetes said that they prefer to use CNI. It's much better with how they want to work with it, and it fits them, etc. And last year, the Cloud Native Computing Foundation, which is the foundation that kind of holds all of the really important Dockerish, Cloudish projects under it, decided that they will kind of make a formal standard spec of CNI, and probably Docker will die a slow death. So what's the difference between CNI and CNN? Okay, so with Lib Network, both of them are open source projects on GitHub and everything. So what happens is, when you have a Docker runtime, inside of that Docker runtime, you have the DNS server. You have the database that stores where every service is, etc., okay? All of that information is kind of compiled into the Docker runtime, and that's why they have the native network drivers like Bridge and Overlay. And this Overlay driver there is some magic happening, and that magic is being orchestrated by the Docker daemons. Okay, so if you're using some other runtime to run containers, you cannot use these native drivers. There's also an option to use third-party drivers to connect to Docker using Docker plugin install, etc. On the other hand, on CNI, there is no kind of central place. Each driver is a process running on the host that makes sure to do all the things that need to be done in order to namespace a container correctly. Okay? So when a bridge plugin in CNI is used, first you create a container, then you connect the container to the bridge, and that's the job of the plugin. And it doesn't depend on anything else. Okay? So basically that's the main difference between CNI and CNM.
The main difference is that CNI works with a standard API and plugins, and CNM with some native monolithic.
Not really, because both CNI and CNM do the same thing. They set up namespaces. But with libnetwork, the CNM model, a lot of the magic is in the Docker daemon. Okay? And it's not so good when you want to use other runtimes, not the Docker daemon, but maybe Rocket or Hyper or something else. So CNI is kind of catching on as the better standard. So what happens is there's a config file. That config file is specified by the specification of CNI, and the plugin basically a process that can do two things. It can add a container to networks or delete a container from a network. Now, why is this interesting? Because when you look at, for example, ECS, the orchestrator provided by Amazon AWS, and you take a guy, Adrian Cockcroft, who is a very important technologist. He used to be the technologist of Netflix, and then he went to Battery Ventures for a while, and now he's kind of a very important guy at AWS. He says, well, CNI is the way. Kubernetes also said the same thing. CNI is the way. We will not be supporting Docker's way of doing things. So the problem with this is that it's a little bit too hard to set up a CNI a bridge, for example, with play with Docker, and it would take us much more time. That's why I kind of left it to the last slide, where there are some blog posts that can show you how to do it if you like. One example of CNI is in ECS, every container can receive its own elastic network interface. So if you're familiar with Amazon a little bit, there's a resource called Elastic Network Interface. It has an IP address, a public, a private IP address. And what happens is when you create a container and you say, I want to have ENI connected to it, there is a CNI plugin, again, open source, released by AWS, that does the work of creating the ENI and connecting it to the container. Okay, so basically it's a script or an application that does all this API calls and all this connecting and stuff. And the way it works is there's a standard called CNI, and that's how it works. There's a free book that you can download to learn everything you want to know about CNI. It's offered by nginx. And there's a blog post by this guy who kind of shows you step by step how to create a CNI driver, how to use it, how to use it with Docker. Really interesting. Quite a bit more advanced than what we have time for today. So, about networking, are there any more questions? I didn't cover all networking, we just, okay. So let's jump into volumes. Of course, when you have CNI in networking, you need to have a C something I in storage, and that is CSI. Again, open source standard under Cloud Native Foundation, I think, or will be. And it was pioneered by EMC because EMC said, well, we have all these big storage boxes, and containers are kind of very hard to set up with these storage boxes, right? So you know what? Wait a second. Let me explain the concept here. So before containers, before cloud, when you needed to create VLANs on the network, right? When you needed to create a storage device, how would that look like in a company? A developer or someone who needs this application to be running would go to the IT person and ask him to create storage, ask him to create a network, ask him to create VLAN, and all of that process would take quite a long time. It would be very difficult. Only that storage admin, only that network admin would know how to configure the Cisco device and all that. Now, in the cloud native applications, that's just not acceptable. You don't want to wait forever for somebody to do something in order for you to get your work done. If you want a service and another service to not see each other on the network and use two different VLANs, you just want to say, I want two different VLANs, let it be so, and it should happen immediately, right? That's why in containers you have these CSI, CNI, all these standards, because the mind is different. There's a mind shift here. It says, if you want to say that this service and this service shouldn't see each other, you should just say so in some configuration line, and that's it, okay? And what happened with storage is EMC came and said, well, we have these storage boxes, and the only way containers can use them is if the storage admin will configure stuff. So let's create a standard like CNI, like the networking standard, but for storage. When a container wants a volume from somewhere, okay, doesn't matter where, it will ask this application to create the volume and give it to him, and that way it can receive a volume. Now, one of the open source projects that was released is RexRay, and it supports creating EBS volumes. It supports creating EFS volumes, S3 fuse file systems, user space file systems. What does this mean? It means that when you create a container, an EBS will be created in Amazon, connected to the host, and connected to the container. And when that container is moving to another host, to a different host, that EBS, that block storage device, will move together to the different host and be connected there, okay? And all of that is being done by RexRay. Is the one who is orchestrating all of this. Understand? So it's a volume abstraction method, and it supports all of the different clouds, and it will support even more stuff later. So you install RexRay on all of the hosts, right? You create a new container, and then it goes and gets you some block device or something and mounts it as a file on that container. And then when that container is moving to a different place, because the orchestrator wanted so, the same data will be mounted under the new location. Cool. Okay, so that's the idea of Docker volumes. Now, I have a short work for you. Again, this is a workshop, you have to work. I cannot use RexRay with Play with Docker, too complex. What this workshop is showing you how to do is how to create a volume in a container by connecting via SSH somewhere, okay? If you have your own place you can connect via SSH to and mount your files via SSH to your container, you're free to do so. It should be very short, should just take a couple, like 10 minutes, 15 minutes. And again, if you have comments or problems, let me know. And don't run away home, because after this, we will be building an image that is 1,000 times smaller than it initially was. So, suspense. Yes. I want to kind of clarify a bit in here. So let me. Okay, so please note that in the second stage, when the SSH command has the SSH command has a user and a host, If you're not on this host, it will probably not work. So you need to be either on this host or change the command to be a suitable command. Okay? Okay, so yeah, and this is a one long line, this thing.
In the end should give a hello world. So the last I wrote hello world.
If you wrote into the file hello world,
no, I didn't. I don't know.
Here you did. This writes into the file.
Okay.
Okay.
Okay. Yeah. Okay.
Okay, so problems, works, doesn't work, finished, cool. And now the jewel prize of the evening. It's going to be short. So when you build images in Docker, which is, you might say, another way to kind of be a developer in the Docker world, there's a document in the Docker documentation that details the best practices of building images in Docker, okay? And for example, it says, well, it's not just building images, it's just in general good practices when you're using Docker. For example, number 2 says, use docker ignore. What is docker ignore? When you type the docker build command and you put that dot at the end, it takes the whole current directory with all the files recursively, uploads it to the Docker daemon, okay? And then Docker daemon executes the Docker file instructions. Terabytes of space. Then you probably want to ignore them because you probably don't want to put them in the container, unless it's on purpose. So it's a good kind of commandment to have. 4, avoid unnecessary packages and files, right? Your resulting Docker image doesn't need to have all of the compiler and all kinds of stuff that you won't be using when you will actually be using that image as a container. One container, one concern. A lot of debate on this one. If you have a container that should be a web load balancer like nginx, don't put your PHP FPM and your PHP files into the same container. Just separate it into a different one. Every line of a Docker file is a layer, and images are built of layers upon layers upon layers. It's like an onion. In a newer layer, you can remove files, but it will not reduce the size of the whole image because it's still there in the previous layer. So try to reduce the number of layers if possible. Try to use the build cache when you already have a certain layer on that daemon and you build again with a small change. Try to keep the things that are small to change and frequent to change at the bottom of your Docker file so the cache will be utilized as much as possible. And I want to kind of teach you how to use multi-stage builds and how you can take it to extremes. Okay? What is multi-stage builds? A Docker file starts with a from line that tells you what is the base image, and then you have instructions. For example, here I install Git, and then I use Git to get something from GitHub, and then I do all kinds of stuff, and then the last command will build a Go executable. Okay? In multi-stage builds, you can have another from line, and starting from that from line will be a new image. But the nice thing about it is that, as you can see from this copy command, you can copy files from the first image using multi-stage. So in the first image, you don't really care that it takes like a gigabyte or something. You just need 1 or 2 files out of there, but you need to produce them. So you do need the compiler and everything, and Git and everything. But once you produce those files, you don't care about Git, you don't care about the compiler, you don't want any of that, you just want the files. And multi-stage build is a way to copy it. So this is a learn by doing multi-stage builds tutorial. that will start with a regular image that most of you would probably do in your daily job and be kind of content with. And after a couple of iterations, the resulting image will be 1,000 times smaller, even more than 1,000. So if you're not impressed by that, I don't know. And this is also kind of the last slide. The next slide is some reference material, which you probably will copy when I share the slides, and more questions if you like, I'm here. So has the image been shrunk and shrunk and shrunk? Yes? Hopefully nobody is still on the first stage with the huge image. So you can trust me and kind of peek at the end and see that it is possible to make it very small. It does require to think out of the box, like it's not just the Docker problem, it may be an application problem. And you're of course welcome to remain here and complete this task and other tasks. I will share the slides. There's a slide here with some references, with some kind of reading material that I used in order to build this, more than we discussed. And if you would like to ask me questions, or anybody else wearing the prodops t-shirt, just fire away.